Hello, my name is Presing and my student number is ST20335975 and I am going to present my presentation for algorithm and design and analysis, which is based on design and analysis of an intelligent task scheduling algorithm for cloud computing environment. So moreover, this is my content. I am introduce first. First, I want to introduce by introduction, then problem statement, then literature review, then need for algorithm design, then proposed hybrid scheduling solution, then block diagram, flow chart, and compatibility analysis, project timetable conclusion as well, and then reference. So basically, cloud computing allows user to pay on per use basic to gain access into the shared computing facilities, including virtual machines and storage resources on their demands. Nonetheless, the efficiency of a cloud environment generally relies on the efficiency of tasks being scheduled in incoming resources. Poor scheduling of tasks may result in more delays, utilization of resources, high cost, and low quality of services. Therefore, minimize total extension time, better resource exploitation, lesser energy, and use equality and balanced distribution of workloads. According to the author, is in ensuring reliable and scaled cloud services, efficient scheduling is a requirement. Practically, practically none of the classical scheduling algorithm mattering and perform excellently in view of the fact that cloud environments are unpredictable, dynamic, and heterogeneous. The workloads may be considerably varied. Arrival rate of tasks in random and virtual machines are not the same in their processing capabilities. The change cannot be adaptable The change cannot be adaptable to these types of change by the traditional or fixed scheduling algorithm. And result is uneven loads and resource inefficiency. Thus, the research aim at developing a smart hybrid algorithm or scheduling to enhance the extension time and load balance of cloud computing system. Objective: create a smart hybrid task which is scheduling to based on cloud computing. Furthermore, literature review classical scheduling algorithm, which is a number of classical scheduling algorithms have been employed in the past, like the first come, first service, which is called by FCFS, is easy and even but not very good in cases where the tasks are of different sizes, like round robin calculates task based on time slides. However, it is not effective in long running tasks or those that require large resources and minimize choose the task the last shortest time to complete, which give fast scheduling. However, the load the load of this become unevenly distributed among virtual machines. The max minimize and inverse strategy is generally more efficient when the workloads are on in a diverse heterogeneous. Dynamic cloud workload are not served by the classical algorithm through they can be used to offer useful baselines as well. Moreover, modern scheduling approach, recent scheduling studying on the meta-heuristic algorithm, including genetic algorithm, practice phone algorithm, and colony algorithm. They are biological or natural in natural, and these algorithms can be globalized to achieve optimization. It has been demonstrated by the hybrid algorithm have a higher approximation to do much better than method of single approach. Genetic algorithm provide a good global search ability, whereas min is efficient in local optimization. This technique may be integrated to come up with a scheduling technique that is fast and flexible at the same time. This is what the hybrid design is based on basically. So they will also identify the gap which is in hybrid algorithm, which combine both min of a local efficiency. Basically, the hybrid improving min algorithm and a genetic algorithm is a solution to the schedule proposed in the project. The first step is min to obtain is efficient initial schedule through determining what tasks have the shortest estimated completion time. This schedule is then optimized with the help of genetic algorithm using the mutation, selection, and crossover as uh, evolutionary operations. This hybrid solution has the trade-off between speed, flexibility, and accuracy. It further facilitates dynamic mapping of resources, adaptive genetic function, and less mixspan, which is combination improve the overall scheduling program, which is the best key feature I think in this solution overview. Basically, algorithm design justification. Here is the benefit of combination of min-min with genetic algorithm. Min-min saves a preliminary scheduling time, providing the hybrid approach, like with a sold beginning time providing, and basically mapping quality is then enhanced with the help of genetic algorithm which search a larger solution sphere through a distribution and enhance flexibility to non-homogeneous virtual machine capacities. The hybrid scheduling, basically the hybrid scheduling method have always show superiority over classical algorithm is making reduction and throughput improvement and scalability to large cloud data courses, which is best benefits for this. However, there is my block diagram which shows the workflow of purposed hybrid scheduling system. The first phase is the task of gathering user tasks. These activities are then purposed to know what they need in terms of resources. The first stage of the scheduling is done by a min-min algorithm. The result of this is then fed into the genetic algorithm that performs selection, the schedule, and crossover and mutation to output to enhance the schedule. The fitness evaluation module is the measurement of the mix span and load balance. The optical schedule is closed at the final output. So basically, as moving to flowchart, this is my flowchart which describe the logistical order of the stages of hybrid process of scheduling, like the incoming tasks are loaded into the system and the expected completion time estimated by into the system and uses by min-min. They create the first schedule and then the genetic algorithm starts optimization cycle, recurrently applied is selection, crossover of mutation, fitness measures are used in it accepted. Otherwise, the algorithm keeps searching, the process is repeated until the termination condition is arrived, then the best schedule is generated. However, the complexity wise, the minimum stage of is of complex order or n, with the being the amount of tasks, the compatibility complexity of genetic algorithm is O, which is in formula like G multiplied by P and multiplied by N, is which it will be which G is the amount of generation and P is the population size. As such, the complexity of the hybrid algorithm are on on 2 plus g into p multiplied by n. This make calculating cost more expensive, but the benefit is that an optimized schedule would be produced and it performs is the dynamic clouds with increased greatly. So basically, this is my project timeline, which I done by week. So this is my full preparation of my presentation, and now I am going to the last part of this presentation to the conclusion. I will clearly explain you my conclusion how this project and this presentation will be in that correct part in the correct way. I will tell you. So basically, this is my conclusion. Like, it is critical to the note that the take scheduling is critical in realizing effective cloud service delivery all through the classical algorithm offer easy and quick solution. They do not allow flexibility in response to a dynamic workload. methodistic method have greater word optimization. The purpose hybrid method that integrate the min and generative algorithm offer a good equilibrium of customization and quality of scheduling. The work on implementing the model with the use of cloud sim, testing it with real world workloads and extension of the model to energy aware scheduling become a part of future work. Thank you. This is my presentation. Thank you very much.